Outage Postmortem, a DevOps Postmortem. It's 5:30 p.m. PT on January 10, 2014. On paper, it's just another routine maintenance window, a standard OS upgrade for a handful of machines in the fleet. But within 30 minutes, routine transforms into a full-blown catastrophe. Suddenly, the site goes dark. It isn't just a glitch. It's a total blackout of service as core components begin to fail simultaneously. You can almost feel the shift in the room when you realize that something fundamental has broken at the infrastructure level. The scale is massive, and while the engineers are scrambling to find out why the systems aren't responding, the clock is ticking against a mounting wall of silence from the production environment. Something hidden in an automated script just tore through the heart of the network, and by the time the first alerts scream across the monitors, the scope of the damage is already staggering. Picture this, it's early 2014, and for millions of people, Dropbox isn't just an app. It is the literal vault where their photos, documents, and memories live online. It was the backbone of personal and professional data storage. On January 10th, things were supposed to be routine, a standard maintenance window to upgrade operating systems across some machines. But in the world of infrastructure, routine can turn into a nightmare in seconds if your automation has a blind spot. A subtle bug in an automated script failed to verify the state of active production hardware before firing off commands. Instead of skipping busy nodes, the script nuked several critical master-replica database pairs. By 5:30 p.m. PT, that simple OS update morphed into a full-scale blackout, effectively locking out users from their own files and turning a scheduled task into a high-stakes recovery operation. It was early afternoon in California, and for most people, it was just another day of moving files into the cloud. Everything felt stable until it wasn't. On January 10, 2014, at exactly 5:30 p.m. PT, the team initiated what was supposed to be a routine operation, a planned maintenance window to upgrade the operating systems on several machines. They were relying on an automated script designed to handle these upgrades across the fleet. It looked like standard procedure, a set-it-and-forget-it task that should have been invisible to the end user. But there was a ghost in the machine, a subtle bug buried deep in that automation logic. Instead of verifying which servers were currently active or idle, the script began blindly executing commands. It didn't care about state. It only saw targets, and some of those targets were the critical master-replica database pairs holding the entire site together. It was Friday afternoon, January 10, 2014, and for most people in the office, it was time to start winding down. But at exactly 5:30 p.m. PT, the routine maintenance window kicked off a planned OS upgrade across a handful of machines. It started small, but within 30 minutes, the atmosphere shifted from calm to chaos as the service abruptly went offline. The engineers didn't see a massive wave of errors hitting every server. Instead, they were staring at a ghost in the machine. A subtle bug in an automated script had misidentified active production machines as candidates for reinstallation. Specifically, it targeted critical master-replica database pairs. By 6 p.m. PT, the site wasn't just lagging, it was dark. What should have been a standard update turned into a frantic scramble to figure out why core infrastructure was suddenly vanishing from the map. It started at 5:30 p.m. PT on January 10, 2014, during what was supposed to be routine maintenance, a standard OS upgrade across some production machines. But there was a ghost in the script. A subtle bug meant the automation didn't check if a machine was active. It just fired blindly. Within 30 minutes, this logic flaw triggered a catastrophic cascade as the script began reinstalling live production hardware. It hit the master-replica database pairs directly, effectively wiping out the heart of the system. By 6 p.m. PT, the service went offline abruptly. The site stayed dark until 8 p.m., and even then, users couldn't log in for another 30 minutes. While most functionality crawled back online within 3 hours, the sheer scale of those massive databases meant the core service wouldn't fully recover until late Sunday afternoon, January 12th. One bad line of code turned a minor update into a multi-day nightmare. So here is where things went from routine maintenance to total catastrophe. The culprit wasn't a massive DDoS or a rogue hacker. It was a single, incredibly subtle bug buried within an automated operating system upgrade script. This script was supposed to identify inactive machines for patching, but instead, it failed to verify the actual state of the hardware it was hitting. Because the logic was flawed, the automation began reinstalling active production machines as if they were fresh builds. Specifically, it targeted critical master-replica database pairs. By wiping these core components during that 5:30 p.m. PT window on January 10, 2014, the script effectively lobotomized the site's ability to serve data. It turned a standard OS update into a scorched earth event, because the automation lacked even one basic check to confirm a server was safe to touch before executing its commands. One bad line of code and suddenly, the heart of the infrastructure was being deleted by its own caretaker. Imagine the silence of a site going dark during what was supposed to be routine maintenance. At 5:30 p.m. PT on January 10, 2014, a subtle bug in an automated OS upgrade script turned into a catastrophe. It didn't just hit one corner of the house. It took down the entire foundation by nuking critical master-replica database pairs. By 6 p.m. PT, the service had vanished from the public eye. While the front door appeared to reopen at 8:00 p.m. and users could log back in by 8:30 p.m., that was just a veneer of normalcy over a broken core. Because those massive databases were so gargantuan, the full restoration of the core service wouldn't actually finish until 4:04 p.m. PT on January 12th. That's nearly 2 full days of high-stakes firefighting just to get the gears turning again after one script failed to check its own state. At 5:30 p.m. PT on January 10, 2014, what started as routine maintenance turned into a frantic scramble. The team didn't realize it at first, but an automated OS upgrade script had just tripped over its own feet. Instead of skipping active machines, it blindly nuked them, specifically targeting critical master-replica database pairs. By 6:00 p.m. PT, the site went dark, and the room shifted from routine work to full-blown crisis mode. We weren't just fighting a bug. We were digging out of a hole created by our own automation. While most functionality crawled back online around 8 p.m. PT, the real war was the recovery of those massive databases. Because of their sheer size, restoring every core service took us until late Sunday afternoon, finally wrapping up fully at 4:40 p.m. PT on January 12. It was a long, grueling marathon against the clock. The fix wasn't just about flipping a switch. It was a grueling manual excavation through the wreckage. To get things moving, the team had to perform full recoveries from backups, which is always a gut-wrenching process when you're watching the clock tick. While most functionality crawled back online within 3 hours, the sheer scale of some databases meant the core service wouldn't fully restore until 4:40 p.m. PT on January 12, 2014. But we couldn't just patch and pray. The long-term fix involved stripping that subtle bug out of the automation logic entirely. They implemented mandatory local state verification, forcing every machine to double-check its own status before executing any incoming commands. By ensuring the upgrade script explicitly confirms if a server is active before touching it, They moved away from blind execution toward a guarded, defensive architecture, making sure no automated script could ever mistake a critical production master for an idle target again. Look, if there's one thing this mess taught us, it's that automated doesn't mean set it and forget it. When an OS upgrade script decides to treat active master-replica database pairs like disposable hardware, you've got a systemic failure in trust. The lesson here is simple. Never let a remote command execute without a local sanity check first. A machine needs to verify its own state, its heartbeat, its role, its very existence before it lets a script touch its core processes. We need layers of defense where the infrastructure itself says no to destructive actions on critical systems. Furthermore, as your scale grows, testing just be about functionality. It has to be about edge cases. That subtle bug shouldn't have made it past staging because the automation didn't account for live production variables. If a script can't distinguish between a dormant node and a primary database, it isn't ready for prime time. That's how Dropbox turned a very bad day into a lesson. If this saved you an outage, subscribe for the next postmortem.